Welcome to Digital Electronics Lecture 2 Part 2. We will discuss about implications of De Morgan's theorem. In the previous lecture, we discussed about a couple of theorems and De Morgan's theorem. So now the implication of De Morgan's theorem. Just look at the De Morgan's theorem, this one. We have x plus y prime equals x prime into y prime. So if you look at carefully, the left hand side of the equation can be viewed as the output of a NOR gate with input x and y. So this is basically, this can be implemented using the NOR gate. If you look at here, just wait a minute, I better use a marker, maybe pointer to be helpful. Okay, so just look at here, x and y and OR gate x plus y prime. So this part can be implemented using NOR gate. And look at the right hand side. So right hand side of the equation is the result of first inverting both x and y input and then putting them through an AND gate. So this is x invert, y invert, then putting them together using AND gate. Just look at here, x invert, y invert, and putting them together as a AND gate. So this is, if x and y is our input, the output will be x prime dot y prime, which is basically x plus y whole prime. Also, if you look at here, x plus y prime, so that could be written as x as x prime with inverter, y as y prime. So the output of this AND gate will be x prime dot y prime, which will be equal to x plus y whole prime. So that can be implemented. So this set can be implemented using OR gate, and this set can be implemented using AND gate. Simplification of De Morgan, the second part, x dot y prime equals x prime plus y prime. The left side of the equation can be viewed as output of NAND gate. So this set can be implemented using NAND gate, and right hand side of the equation, first inverting both x and y input and then putting them through OR gate. So now it is OR gate, reversely it was AND gate. So just look at here, x dot y prime. So x and y, and it will be inverted output. So x and y, if it is AND gate, then it will be x dot y. As it is inverter, so there is a bubble. So this is basically an AND gate. So x dot y prime. That can be also written as something like that. X as x prime with inverter, y with y prime as inverter. And if you use the OR gate, then it becomes x prime plus y prime equals x dot y prime. And the right hand side, x prime plus y prime. So this is OR plus sign, so we need to use OR gate. So x and y, so it becomes x prime plus y prime, which is basically x dot y prime. Here we'll try to solve a couple of examples. So the question says, prove the following theorems algebraically. So we already saw a couple of theorems around 16 or 18. So we just need to use that theorem to simplify that. So the first one says x into x prime plus y. Solve it how it becomes xy. So if we write it here, x into x prime plus y, so we need to prove it as xy. So just multiply it, x into x prime and x into y, so which is known as distribution law. So whenever you're using any of the law, you need to write it within first bracket. You need to put the number like rule 1, rule 2, rule 3, whatever. Otherwise you need to write the rule name, otherwise you don't get full marks. So x into x prime, that again becomes 0, complementary rule, and xy becomes xy. So this left hand side becomes xy. So this is proved. Go to the second one, B. It says x plus xy equals x. So if you take the common, so x can be written as x into 1 and xy as xy. If you take the common on x, so it becomes 1 plus y, which is x. So you need to write the rule number or rule name, which one you are using, which is not shown here, but you need to show it. Again, C xy plus xy prime. So if you take the common, then y prime, y plus y prime equals 1, then x into 1 becomes x. So it becomes x. So last one I keep it for you. This is the assignment. So try to solve it by yourself. So D. So it will be showed after you've done your assignment. Another question. Simplify each of the following expression by applying one theorem only. So you can just use only one theorem. Let's look at the first one. So first one says x prime into y prime into z plus first bracket x prime into y prime into z whole prime. First bracket complete and whole prime. So if you look at here, just wait here, I use again the maybe the laser pointer. Okay. So we are here. So we know x into x prime equals 1. So if we consider this one as x prime y prime into z, and this become x prime, so we can directly write it as a 1. So you need to write the law or number, equation number, which you saw in the last video. If you look at here, b a b prime plus cd plus b prime e plus cd. So here also we can use that equation x plus y into z equals x plus y into x plus z. So if you consider cd as x, so it becomes x plus y, x plus z. So which is x plus yz. So which become x is your cd, yz becomes a b prime and b prime e, b prime e. Again this line, so cd becomes cd, b prime becomes b prime actually, so a b prime e. That's really true. This two becomes 1. The same thing for c. I think you can do it by yourself. I'm not going. It's also shown here, and also last part is for your assignment. Convert the following to simplified SOP. We haven't discussed what is SOP is actually. We'll discuss it in the next lecture hopefully. SOP is sum of product, and in the next slide you will see POS, product of sum. Sum of product means actually this is all multiplied together, so that is called product of sum. A sum on product means the product are summing together, like these two product summed through this plus sign. So this is called sum of product. So you need to convert that POS, that means product of sum, into sum of product. So just look at here. So you have a plus b into c plus b into d prime plus b into a c d prime plus e. So if you rearrange it, so which is called commutative law, so you see b, this one becomes first and this one becomes second, and this first one becomes third and fourth becomes fourth, as it is. And again if you use this law, x plus y into x plus z, which is x plus yz. Now it looks like you are going from POS to SOP. So this is your POS. So you are going from this side to this side, x plus yz. Okay. So if you consider this, then b is your x. So x plus y x plus z, then b plus cd prime, so b plus cd prime, and then again b plus cd prime, a plus b, a cd prime plus e. So again you may get something common, bb. This is your x, this is your x plus y, x plus z. Then it becomes b plus ac d prime, becomes b plus c. And again here you get something common, this one common, so this is your x, so x plus y, x plus z, x plus y z. Then it becomes ac d prime plus de. So just using only single equation, so you can solve it. So this is actually sum of product. And the second part, which is hidden for you, this is your assignment. Try to solve it by yourself. If not, then I'll help you in the lecture. So just look at this equation carefully. X plus yz equals x plus y, x plus z. We are trying to go this side, right hand side from left hand side. So if you consider here ab plus c prime, so c prime as your x and a as your y, z as your b, so it becomes c prime plus a, c prime plus b, c prime plus a, c prime plus b, something like that, or a plus c prime, whatever you write. This is also same. This is your x, d prime is your x, and a as your y, b as your b. So d prime plus a, d prime plus d. So d prime plus a, d prime plus b. Or you can write it a plus d prime into b plus d prime. So second part is also same. So it is showed here. I think you can solve it. And last part is for your assignment. So last two is your assignment. Try to solve it by yourself. If not, we'll discuss this in the class actually. Okay, so this is the last example of this type. So it says simplify each of the following expression by applying one theorem only. So if you look at the first one, x plus y prime z into x plus y prime z whole prime. So if we consider x plus y prime z x, so this become x prime. So this product become x dot x prime. X dot x prime equals 0. We know that from the initial couple of slides. So this product becomes 0. Look at the second part, p. p prime w plus x whole prime into x plus y plus z plus p prime w. If you look at this one, p prime w plus x, this term also remain here. So like p prime w and x, first and last, put first and last together, and it becomes y plus z. So if you consider, say, this one as x, p prime w plus x, and this one as y, so it becomes x plus y into y, something like that. So considering comparing with similar kind of equation which you know from initial couple of slides, so then it becomes b prime w plus x whole prime into y plus z. Just replace your x and y. If you consider, say, like this one as y, then it becomes this one as y prime and this one as x, and later on just put the values using this equation. So you'll find b prime w plus x whole prime into y plus z. The last part is d. So I didn't show the answer. I gave it to you for assignment. Try to solve it by yourself. If you find any difficulty, then we'll discuss in class. Thank you. I'll see you in the next lecture.